So the next thing I want to show is just really quickly want to go over one of the most important mechanisms of this chapter dealing with alcohols in organic chemistry. And the one of the most important reactions here is this reaction with thionyl chloride. So converting an alcohol with thionyl chloride into a good leaving group. And this is very useful because you're going to be able to have this tool available to you for retrosynthetic analysis problems. And professors, especially in free response exams, they really like to use this problem here, or this reagent. So you really have to know this reaction mechanism. So I'm going to go ahead and go over that really quickly. And so I'm going to show you how you get from a secondary alcohol in this case to a secondary alkyl halide here with inversion of stereochemistry. So really quickly, let's go ahead and walk through that. So I have my secondary alcohol here. So, and as we go through this, you should be trying to figure out what this is called, the name of this molecule, and if you guessed 2R butanol, then you are correct. So let's go ahead so the important thing here to do is to draw out. So we have to draw out thionyl chloride. We have to draw out thionyl chloride like that. And so first thing that happens is, again, the hydroxyl here, the oxygen acts as a nucleophile, and it's going to attack that sulfur atom right there. And as it does that, the chloride right here is going to leave. So the electrons from that bond are going to jump on chloride, and chloride is going to leave, leaving us with something like this. So the important thing to know here is that in this first reaction, in the first step of this reaction, you have retention of stereochemistry. Again, and I'm going to have plus chloride. So we have retention of stereochemistry. Why is that? Well, because we aren't breaking any bonds, so we are not doing anything to that bond right there. That bond is the one, it's staying put. It's not doing anything. Oxygen is the one that's attacking the sulfur. So we are not breaking that bond, therefore you don't do anything with stereochemistry here. And again, remember, the chlorine left, one of the chlorines left, therefore forming chloride, and we still have that hydrogen here attached to that oxygen right there. So therefore we form something, with sort of a hydronium moiety here, but with the sulfur and the chloride. So it's a little funky, but that's the intermediate here that we get from the beginning of this reaction. So what happens next is so the importance of pyridine comes into play here. And I really don't like using the word pyridine under the arrow. I would rather draw it out. So I like to draw out pyridine. It's just my preference here, because it helps me visualize what I'm looking at. So, and just a little bit of pyridine goes a long way, because pyridine serves to deprotonate that hydrogen right there and get rid of that positive charge on oxygen, right? And so the result from that, I'm going to put on the next slide. So the result of that is going to be this right there. Okay, awesome. So now we have our intermediate here, and what's going to happen next is the chloride that we made in solution earlier is now going to come in and do backside attack on that carbon right there, and because of that, the electrons from this bond now do jump on oxygen, and now you are breaking that bond. So because you're breaking that bond now, and it was backside attack, remember that's classic SN2. So classic SN2 is backside attack, and because you got backside attack, now you have to invert the stereochemistry. And so we are breaking the bond between oxygen and carbon, and we're forming a new bond between chlorine and carbon. And so now that gives us our final product here, which is that. And you form your byproduct here. With your byproducts, eventually, you know, there's going to be some rearrangement here, and you're going to form SO2 plus Cl against, or chloride, excuse me. That doesn't matter really. I mean, on a thermodynamic scale, it does matter because the formation of sulfuric acid, or excuse me, the formation of sulfur dioxide it's what's actually driving this mechanism thermodynamically from an entropy standpoint. But we don't want to worry about the details as far as the mechanism for that. All we really care about is what's happening here. We just really care about this product here. So don't really worry too much about the mechanism for sulfur dioxide. But yes, if this was a thermodynamics course, yes, it would matter. But it's not. So this is all we really care about is our final product here. So that's how you get this final product with inversion of stereochemistry using thionyl chloride.